Okay, welcome. This is the lecture for section 4.3. I will be posting this online. I will also attempt to post it on Canvas, as well as it will be uploaded to YouTube. Okay, so today we're doing solving systems of linear equations by the addition method. Last class we did substitution. This class we're going to do addition method, sometimes also referred to as elimination, because we eliminate a variable by adding the equations together. All right, so practice changing equations into standard form. It is necessary for this to be the equations to be in standard form if you're going to add them together. That's just the way it works. Okay, there we go. So 5y minus this is in standard form. Notice that the x term is first, then the y term. That's the problem. Okay, so standard form, we've got to flip so that x is first. That's all it is. Now remember, when it's a subtraction, that makes it a negative when we move it up front. Okay, on this next one, we've got to subtract the y to the other side. So we end up with 4x minus y equals 1. For number 3 here, we want no fractions. So what we're going to do is multiply everything by 10. And that's going to get rid of that denominator there, the 1/10. But when I do that, I'm going to get 10x minus y. Because 1/10 times 10 is 1. And then 10 times 10 for my constant, so that becomes 100. So that is now in standard form. Okay. Sorry, I'm drawing lines all over it because I need to shift it, and I'm still remembering how to use this program. Okay. Now, this one is, number 4 here is in standard form, kind of. It has the fractions, so we have to get rid of those. So I'm going to multiply the whole thing by 5. And that's going to get rid of the 5 denominator. So I now am going to have 5 times 1/8 is 8. Whoops. Over 8 x plus 3y equals 19 times 5. So that's going to be 100 minus 5, which is 95. Okay, now I have to get rid of the 8. So once again, I'm going to... Okay, now I'm multiplying the whole thing by 8. And that's going to get rid of that 8 denominator. So when I multiply it times the 5/8 x, I get 5x. Times the 3, I get 8 times 3 is 24. And times 95, I'm going to get... Let's see, putting in my calculator. All right, I'm going to get 760. Okay, and that is my answer. Now, solving linear systems by the addition method. Consider this system. So what we do is we're going to add the two equations together. What we'd have to set this up to do is so that one of them, the whole point, is to get rid of one of the variables. So as you can see here, I've gotten rid of the y variable because a plus y and a minus y, when added together, go away. And I'm going to get 2x, and then I get 12 plus 14 is 16. I can continue finishing this, and I would get, by dividing both sides by 2, I would get x equals 8. All right, then I can plug that back in, that 8 in, into either of the two equations and get the y equals 4 that you see here. So that my final answer would be 8, 4. All right, now given that we have That's the process. Here are the actual steps. Okay, if necessary, rewrite both equations in standard form, because every once in a while you'll get an equation that looks something like this. And that we can't do. We can't line these up properly. So we have to get that 4y on the other side. So we rewrite it as something like that. Okay, we've moved that 4y to the other side, and now it's in the proper form. That's number one. Number two, if necessary, multiply either equation or both equation by an appropriate non-zero number so that we can eliminate one of our variables. So again, if I had something like and let's say 3x plus 2y equals 7. Okay, now notice I can't easily add these and get rid of something. So if I multiplied through this entire equation by -2, that would give me -6x minus 2y equals -10. So now I could add these and it would go away. The y values would go away. So here I have multiplied by a non-zero number, -2, and gotten an equation. It's an identical equation. It just has a slightly different form. So I'm able to add these together and get rid of the y values. That's what number 2 is saying. Number 3, add the equations in step 2. So that's what we would do. We would add these two together. Eliminating the y, here I would get -3x equals -3. Wow, that's going to come out nice. All right, solve the equation. So I end up with x equals, by dividing both sides by -3, I get x equals 1. Then I could plug it back in and get my other value. That's what back substitution is called. Okay, it's taking that x value, the y, x value of 1, and I'm going to plug it into this equation right there for that x. All right, so what I would get would be 2 times x, 2 times 1 is 2, plus y equals 5, subtract 2, y is 3. So my answer would be 1, 3. Okay, that's basically the process we're going to be using. Okay, now here's some more examples. All right, now notice I can't add these and lose anything, but if I multiply this equation by a +3, that would make my y -3, and I could add the two y's together and get a 0. So I'm going to rewrite the first equation. And now the new second equation, times 3, is going to give me 15x minus 3y equals 3 times 11 is 33. Now I can add these two together. Whoops, that's an ugly 3. There we go. These two are going to cross out. 2x plus 15x is 17x. 18 plus 33 is 41. All right, and now I divide both sides by 17, and I get x equals 3, because 3 times 17 is 41. There we go. All right, so if x is 3, then I take that and plug it back into one of my equations. So let's say I need to keep my equation on the picture. All right, 2x, so 2 times 3 plus 3y equals 18. Well, 2 times 3 is 6. Now I subtract the 6 from both sides. I get 3y equals 12. I divide both sides by 3, and I have y equals 4. So my final answer for this one would be 3, 4. Okay, and now we're on to number 2. Now, I could multiply this by either -2 or -3, depending on which one I want to get rid of. Since I've done y a lot, gotten rid of y a lot, I'm going to do it on the x. So I'm going to multiply this equation by -2. Plus, it's a slightly smaller number than 3. Okay, so this gives me 2x plus 3y equals 9, and a minus 2x minus 2y equals -6. If I add these together, the 2x's go away. 3y minus 2y leaves me with just y. 9 minus 6 is 3. So there we go. Y equals 3. Plug that back in. X plus 3 equals 3. If I subtract 3 from both sides, x is 0. So my answer to this one would be 0, 3. All right, moving on to number 3. X plus y. Okay, so now these I can go ahead and add because I'll get rid of those y's. So the y's cross out. I have 3x equals 5 minus 11 is -6. I divide by 3. I'm going to have x equals -2. Plug that in. I have -2 plus y equals 5. I add 2 to both sides. Y equals 7. My answer is going to be -2, 7. Okay, and number 4. Okay, this one's easy. I'm just going to multiply the bottom equation by -1. And what that does is merely change all the signs. So now I have the x's cross out. 2y minus 3y leaves me with a -y equals 5 minus 7, or -2. I'll multiply through by -1, and that gives me y equals 2. Plug that in. X plus 2 times 2 equals 5. Well, that's a 4. So I'm going to subtract 4 from both sides, and I get x equals 1. So my answer is 1, 2. And number 5. Well, neither of those are going to be pretty, but we're going to just have to do it. So let's get rid of the x. No, yep, might as well. All right, we're going to multiply this by 2 and this by 3, because those are the two coefficients of the x's. All right, so when I do that, I get 6x plus 4y equals 20, and I get 6x plus 15y equals 9. Remember, we're distributing this number to all 3 values. All right. Oops, one of those should have been negative. We'll just do it on the bottom one. Negative. So this becomes negative. That becomes negative. And that becomes negative. Now when I add them, the 6x's are going to go away. I have -11y equals 11. Divide both sides by the -11. Y is 1. Plug it back in. 2x plus 5 times 1. Oh, no, it's not 1. I bet you're jumping up and down at me. It's -1 because this was a positive. Let me change to highlighting so you can see what I'm talking about. This was a positive 11. A positive 20 minus 9 would give me a positive 11. Positive over negative, it had to be a negative. Okay, so 5 times -1 is a -5 equals 3. So if I add 5 to both sides, 2x equals 8. Divide 2, x equals 4. So my answer is going to be 4, -1. Okay, not too bad. Point. Okay, hang on. X. I hit it the next slide. Okay, I get the fun of attempting to get this to be bigger. Okay, let's go back. We do this. Come on, there we are. Come on. All right. 4x minus 8 equals 3y, and x equal... Okay, first off, we're going to have to get this bottom equation into the proper order. Oh, the top one is also. All right, so 4x... Subtract the 3y over. I add the 8 to the other side. Okay, so we did a minus 3y to get it here and a plus 8 to get that one over there. So now we have 3y minus, 4x minus 3y equals 8. All right, now we have to do the same thing with the next one. X, I have to add the 2y equals, the 13 is in the right place. Okay. So now I have x, y, and then the constant on the other side of the equal sign. Yay, this is the right form. All right, now what do? I could multiply top by 2 and bottom by 3 and get rid of the y. I could multiply the bottom by negative 4. Well, I like that better. I only have to do one set of multiplication. So I'm going to have 4x minus 3y equals 8. And then I'm going to take this one and multiply by negative 4. Now, it's going to make me a nasty constant at the end, but that's all right. Negative 4x minus 8y equals, well, that's 4 times 10 is 40, 4 times 3 is 12, 40 and 12 is 52. So I have a negative 52. I add them together. These go away. I have negative 3 and negative 8 gives me a negative 11. Negative 52 and a positive 8 give me negative 44. Yay, that's good because, oops, negative 11y, negative 44. I like that because it's a multiple of 11. The 44 is. Divide by a negative 11. Those disappear. I've got y equals 4. Positive 4. Yay. All right, now we go find x. I'm going to go back to my x equal equation to find x because that will make my life the easiest. So x is equal to 13 minus 2 times y. Y is 4. 13 minus 8 is 5. So x is 5. So my answer is going to be 5, 4. I'm checking to make sure I got the x and the y in the right place. All right, but let's just do a quick double check on the other equation. 4 times my x is 4 times 5. That's 20. Minus 8, does that equal 3 times my y, which is 4. 3 times 4 is 12. 20 minus 8 equals 12. This is true. Okay, we got our answer. Yay. All right, now we're going to check the next one. Okay, 2x minus 6y. There we go. Okay. And a 3x equals. This is a problem. I need it on the other side of the y there. So I've got 2x minus 6y equals 5. And 3x, I have to subtract the 9y to get it to the other side. All right, now I've got them all in order. Okay, I can multiply by 3 and then by 2 to get rid of the x's. But the y's, what do I have to do? I'm still going to have to multiply by 3 and 2 to get the y's to be 18s so they cancel. So let's try this. Okay, so what happens when I multiply the first one by 3? I get 6x minus 18y equals 5. multiply the second equation by a negative 2. I get a negative 6x plus 18y equals negative 4. Well, we're going to have a problem with this. They both disappear. I end up with 0 equals 1. Okay, there may be new math, but I don't think so. That doesn't ever work. Remember when we come up with a solution that is never, ever, ever, ever true. Two constants that are not equal set equal to each other. Never true. This means no solution. They are parallel. So they don't ever cross. There is no solution of these two linear equations. All right, we're moving on to 8. All right, 2/3 x plus 1/6 y. Nasty. We got to get these in standard form. First thing, we're going to get rid of all of the denominators on my first equation. Notice 6 will do the trick, because 6 will get rid of the 3's as well as the 6. So I'm going to take this whole thing and multiply by 6. So that's going to give me, well, when I multiply the 6 times 2/3, the 3's crossed out, but that's going to leave me a 2 out of that 6. So I would have 4. So this is going to be 4x. When I multiply it tied to the 1/6, that just becomes a 1. So I have y. Now when I multiply it by the 2/3, I have the same thing that happened with the 4. Because again, it's 2/3. I'm going to end up with 4. All right, yay, no fractions. Life is so much better. Okay, now the second one, notice I don't have in standard form either. I'm going to have to move the y by subtracting it. So I have 3x minus y equals 12. Well, notice my y's will cancel right now, so I'm going to do that first. Goodbye, y's. 3x plus 4x is 7x, and that's equal to 12 plus 4, which is 16. Well, that's not pretty. X is going to equal 16 sevenths. Okay, I'm going to double check my math just to be sure I'm correct, because that's not a pretty answer. Sometimes we get not pretty answers, so that's okay. It makes me a little nervous, so I go check. And I don't see I did anything wrong. So we're going to just keep going with this. Okay, 16 sevenths for x. Oh, plugging that in is not going to be pretty. Okay, so 3 times 16 sevenths equals 12 plus y. Well, 3 times 16 sevenths. 3 times 16 is 48. So I have 48 over 7 equals 12 plus y. Got to subtract the 12. All right, the only way I can do this is common denominator, so that 12 needs to be over a 7. So the numerator becomes 12 times 7. 12 times 7 is 84. Okay. 48 minus 84. Okay, minus 50 would be 34. And add 2, 36. So I've got 36 over 7 equals y. That's just not pretty. Okay, so that means my answer is 16 over 7, comma 36 over 7. All right, we are definitely going to check that one out. Okay, so we used this one to find our point. So it's obviously going to satisfy that because we did the math for it. So we're going to check it in the one with all the fractions. No, that's just awful. Okay. 2/3 times 16 sevenths plus 1/6 times 36 sevenths equals 2/3. Okay. Now, this 6, thankfully, crosses off with the 36, turning this into a 6 up here. So I actually have 6/7. But I need the 3, don't I? I do. Because I have 21 right here, so I'm going to need the 3. Okay, I think instead of crossing out the 6, because I need the, I need the 3. I've got 21 here, so I'm going to cross out the 2 and leave a 3 behind, and that leaves me with an 18. So now I have 18 over 21, and I have 2 times 16 is 32 plus 18. All of this over 21. So 32 plus 18 is 42 is 50. Okay, that's not working either. All right, I'm going to pause it. I'm going to go figure out what I did wrong, and I'll be right back. For you, it's going to seem like instantaneous. Okay, I'm back. Now, I think my problem was that, this was supposed to be a negative. It's supposed to be a negative 36/7. So if I do that, then I end up with, let me get rid of this. This 18, come on. Really? You're going to do that to me? Apparently it is. All right. It's going to take me a while to get rid of the, okay, that's close enough. Okay, so this is going to become a minus right here. 32 minus 18 is 14. That's what I wanted. So what I actually have is 14 over 21. Both divisible by 7, leaving 2/3. So that's my answer. But see, it helped me find my mistake. So my answer is negative 36 over 7 for my y value. Okay, so this then is my complete and accurate answer. The negative. All right, now we're going to move on to 9. And it looks like that's going to be the end of it. Okay. All right, so let's do number 9. 7x plus 12y. And we're going to get rid of our fraction by multiplying through by 2. So I have 7x plus 12y equals 4. I notice when I multiply the 2 times the 6, I'm going to get 12. So I'm going to do a negative 2, okay? Negative 2. So in this case, negative 2 would give me a negative 7x, minus 12y, these are all going to disappear, equals negative 4. That one disappears. This means we have an infinite solutions. They were actually the same line. If I had not done the negative, I would have ended up with 7x plus 12y equals 4, and you'd see exactly they were the exact same line. So 0, 0, my answer is infinite solutions. Same line. Okay. There we go. And we're done. So I will get this all uploaded.